In this recording, we're going to learn about something called the axis of symmetry. So as the name implies, the axis of symmetry is a line of symmetry that cuts the parabola in half, divides it right down the middle. And it's related to these zeros. So we're going to start out by having you find the zeros. That's when the x value when y equals 0. So we want to know, what are the zeros? What are the x values when y equals 0? So for this first one, you can just see the places where y equals 0 are x equals -4 and also 0. Sometimes we like to enclose these in a set brace, so we'll do that here. I would like you to figure out the second and third example. Play the recording when you're ready. Okay, for this one, there's just x equals -2. And for this last example, there are no zeros. So what is the axis of symmetry? Well, if you could take a ruler or an edge and put it in such a way where it would divide the parabola right down the middle, where would you put it for this parabola right here? And hopefully you'd put it right here, right? Notice how it's right in between the zeros. This line, this axis of symmetry, splits the parabola in half. If you were to fold it on this line, the parabola would fold on top of the left side. We often draw the axis of symmetry as a dotted line because it's not really part of the graph, but it can be drawn. Now this one's kind of in the middle of 2 and 3. That happens sometimes where the axis of symmetry is not on an integer. Okay, so let's get a definition here. The axis of symmetry is a vertical line, we saw that, divides the parabola into two congruent, or in other words, equal halves. That's what congruent means. The axis of symmetry always passes through the vertex, right? We can see that here. The lowest point or the highest point, the turning point of the graph. The x-coordinate of the vertex is the equation of the axis of symmetry. Okay, that's what the equation tells us. So it's always an x equals type of equation because it's a vertical line where all the x values are the same. So in this case, if you were to draw your vertical line right down the middle, goes through that vertex, well, what would be the x value of all those points? It would be x equals 0, right? Okay, can you draw the vertical line on example 5 and example 6 and then write the equation? It's going to be an x equals equation that describes all the points on that vertical line. Play the recording when you're ready. So hopefully you did something like this. I managed to cover up the number here, but you can see it's between -6 and -2, so it's -4, right? All those points have an x value of -4. Finally, this one, all those values have all those points have an x value of 5. All right, well, what if we don't have a graph? How could we do that? Really, what this should say is for each function. I mean, we know we can represent a function several ways: table, equation, graph. But we don't see the graph here. We just simply have the equation. Now, it turns out there is a formula. We can find the axis of symmetry by finding the negative, or the opposite, the way I'm going to say it this time, the opposite of b divided by 2a. Well, what is this b and a? Well, the a is the number in front of the x squared. So let's write that out. A is the coefficient of x squared. B is the coefficient of x. And c is the constant term, just the number by itself. So when I'm identifying a, b, and c, there's a 1 in front of x squared, so that's our a. There's a 3 in front of x, that's our b, and the c value is positive 4. So when it comes time to find the opposite of b over 2a, the axis of symmetry expression, we're going to substitute opposite of 3 all over 2 times 1. Well, that's 2, right? So negative 3/2. Let me have you work on part B and part C, being very careful about the fact that some of these coefficients are negative, and that's going to make the A, B, or C negative. Hopefully you took time to work those out. Now you can just check your answers. Opposite of B over 2a, that can be simplified 5/3. Positive. Part C. Opposite of B over 2a. So what is the axis of symmetry? Well, the axis of symmetry is the equation x equals negative b, or we'll say opposite of b over 2a. So x equals negative 3 over 2. X equals 5 over 3. That is our axis of symmetry. That is the line that's going to pass through that function vertex vertically. Okay. Now the vertex, we said, well, let's just go back and look at some graphs. The vertex always has the same x value as the axis of symmetry, right? So the vertex would in this case have an x value of negative 2. We just need to use the function to find out what the y value is, the equation. So if I'm working on this algebraically, because I don't have a graph to work with, what I know is, do my work down here, the equation x squared plus 3x plus 4, I'm going to be substituting in that particular x value. So I'll do my work down here. Again, where's this coming from? This is our equation that relates x and y, but I have a specific x value that I'm subbing in, right? It's negative 3 over 2. And now I can just do this math, or we can let our calculator do this math. Okay, so oftentimes with a expression such as this, we're going to want to let our calculator just take care of it for us, so we'll do that in this case. Okay, it came out 7/4. Now, we could have also done this with decimals. If I want to see what this is as a decimal, 7 divided by 4 comes out to be 1.75. So we could either write it with a decimal or the fraction. I guess what I would say is, just to be clean, if you write the x with a decimal, do the y with a decimal as well. All right, so I guess we could say here, or we could have written it with a decimal, x equals negative 1.5. So the y worked out to be 1.75. So we'll write the vertex now as x of 1.5, y of 1.75. Okay, let's show what this would look like with Desmos. All right, so go ahead and open up a browser and go to desmos.com and play the recording when you're ready. Okay, you're going to want to go to the scientific calculator. And we basically want to enter the function, but we're going to substitute 5/3 for the x. Okay? So we have negative 3, and then we're going to substitute in 5/3 square. Okay, and there's the answer, 17.33333. That can also be written as a fraction. Turns out it's 52 over 3. But again, this, if you don't have your own calculator, this Desmos will be a nice tool for you to be able to evaluate some of these at home. Okay, so finally, I want you to evaluate this vertex using Desmos or your calculator. Play the recording when you're ready. Okay, so I'll model it with Desmos. And the y value comes out to be 3. So our x is -1 and our y is 3. Thanks for watching.